Sounds great. Thank you.
Thanks.
Hey everyone, my name is Egor. Oop, sorry, let's do it a little differently. Yeah, perfect. My name is Egor. I'm an Android engineer at Cash App, and today we're going to be talking about testing and the state of Android testing in 2022. We have a packed agenda, so no time to waste. Basically, what we will do is we'll kind of look at the brief history of testing on Android, and actually just like look at how Android as the platform evolved and how the testing tooling evolved with it. Then we'll just look at the testing pyramid, which I'm sure you all are familiar with, but just like to set the context for our talk. The bulk of this talk is going to be very practical. We'll be looking at an example of a simple application, and we'll look on all of the kind of like types of tests that we can write. We'll try to understand why we write certain types of tests, and we'll be looking at a lot of different tools and techniques, like libraries you could use, and in general like tips on how to structure your testing. So hopefully it's going to be the talk is going to be packed with practical advice. So let's just get started. So brief history of Android testing. Let's just look way back into history. And November 2007, that was the kind of like beginnings of Android, I guess. I don't know, maybe some of you read Chet Hass's book called Androids. I really enjoyed it, just like a lot of interesting behind the scenes what was going on with Android. And like one of the larger milestones is the first public beta, which happened in 2007. This is basically where it all started. And it took the team about a year to kind of come to Android 1.0 and release the first device. And the first device was HTC G1, also known as HTC Dream. And here you can see the specs for that device. And this looks like a very constrained environment, right? And it's important to understand that, so we often talk about testing in the context of just architecture. So you can't really like test a code base that's poorly architected. So you kind of want to architect your application in a way that it's easy to test. But when you have an environment so constrained, obviously it limits like the ways you can architect and like the things you can do with just like how you design your code. So this kind of sets the context of what challenges were there for developers at those times. The next huge milestone was the introduction of Android Studio and Gradle as the official build tool for Android, which happened in 2013. And Gradle unlocked a lot of possibilities because Gradle was introduced as a build tool for Java environments. And in say like backend Java environments, testing was already like a lot more mature at that time than in Android. So there was the possibility to kind of just share a lot of knowledge and a lot of approaches from Java backend development through Gradle. Next, it was Espresso, also in 2013. I honestly don't really remember how UI tests looked before Espresso. Like now, when we talk about like end-to-end tests, UI tests, Espresso is just the go-to. Before that, probably was much harder to do it. Right now, it's just like the framework that you would always use for use cases like that. So in 2015, I actually looked this up. This was the first time that Android and the Gradle plugin started supporting local unit tests. So you could actually write unit tests and just run them on your local computer. And that unlocked new possibilities because it's much faster to run tests on your local environment. So before, you would basically just run like instrumentation tests on an emulator or the Android device, which was obviously not so fast. And when you're writing unit tests and when you're writing a lot of unit tests, then of course you want them to run fast. So that was like a really huge milestone as well. And of course, May 2017, this is when Google announced that they will be officially supporting Kotlin. And this kind of turned everything on its head and introduced just like another language to the ecosystem. A year later was the introduction of Android Jetpack, the set of libraries for Android development. And there was a lot of focus on testing as well and just the testability of the libraries. And as you may know, things like ViewModel and just like a more kind of like the more structured approach to designing applications backed by Google was also kind of like drove the testability of applications. And lately, it was 2021 with Jetpack Compose hit 1.0, and there was also kind of like a revolution in how we build UIs and definitely how we test UIs as well. So that was kind of like the stroll down the memory lane. Let's look at the testing pyramid. Just like as a review, I'm sure everybody has seen this many, many times. But essentially, when we're talking about the different types of tests, at the bottom we have the unit tests, which are supposed to be hermetic. So like every test tests, say, one class as like a unit of composition. And so because unit tests are supposed to be small, they're supposed to be fast. So normally we have a lot of unit tests, so that's why it's like a larger layer of the pyramid. Next we have the integration tests. This is the test that would normally integrate a few components. And lastly, at the top of the pyramid, we have end-to-end tests. And obviously they're like much larger. So actually, we can look at those different types of tests from different axes. So for example, when we're talking about integration, obviously like for unit tests, we don't have a lot of integration because we focus on just one class, let's say. But with end-to-end tests, we're integrating a lot. We're integrating multiple components of our application against the Android framework, and normally we would run them on the real hardware, so there's like a lot of components working together. We can talk about cost, and cost can be defined as maybe like how long the tests take to run or how hard they are to maintain. And normally the costs increase with just like the size of test. End-to-end tests are usually more costly. They take a long time to run. You can actually like see monetary value, like if you're using something like Firebase Test Lab, it will actually like give you the report of how much you would pay for running certain tests, depending on like your payment scheme. As for unit tests, they're usually cheaper because they're faster. And lastly, flakiness. And I wanted to point out that flakiness is a very important aspect of testing. And the statement that I want to make is having flaky tests is probably worse than having no tests at all, because this is like when if you have your tests super flaky and they just like fail randomly all the time, developers just stop trusting them, and this kind of like it's a wasted effort because you kind of have those tests, you invested time in them, but nobody really uses them, so it's not really worth having flaky tests. And because like unit tests are focused, there's not too many sources of flakiness. And with end-to-end tests, because we run them on real hardware, like stuff can happen, the device can just crash, a lot of things can happen. So sometimes like the test will fail not because your code is broken, but just because something else happened. Okay, so let's get to the practical part of this talk. We'll be looking at a test app called Stonks because it's about stonks. It's essentially an app that shows your portfolio. Let's say you're just investing in stock, and you have some of the like positions in your portfolio, like the number of shares that you own for certain companies. You just like have them in the list. And the only other use case is filtering your portfolio. So you have like the input field where you could type, and the application is supposed to filter the portfolio by that filter term. And this would be enough functionality for us to look at different types of tests and how we test this application essentially. Even though the application is really small, I kind of wanted to distribute it by layers to really showcase how each layer can be tested. So the way this application is structured is that it has the domain layer, it has the data layer. This is where some of our data sources live, such as network and database. Then we have our presentation layer, and the way this is structured is that we have a module that has our composables, like our UI, a module that has our presenters, and we also have a module that has what we call UI models. So this is essentially the data that is produced by the presenter in a way that makes it easy for the view to render. So our presenter is going to be pulling our data from network or from the database, processing and packing it in such a way that is like super straightforward for our UI to render. So like data optimized for presentation. And lastly, we'll have our app module, just like integrating into our main activity. I'm not going to be looking at it at all, and actually like it's a good advice to architect your app in such a way that you have like pretty thin integration with stuff like activities and services, because that way you can test stuff in more isolation. All right, so we'll start with unit tests. And some of the properties of unit tests, as I mentioned, they're supposed to be hermetic, which means that when you're, say, testing your presenter, you're only testing the presenter. So everything else that the presenter works with has to be mocked out or faked out. So the test only focuses on one single class. Everything else should be substituted by test doubles. This is very important because whatever the failure is, we want to make sure that it comes from that specific component. Unit tests create a safety net for your application. And this is, to be honest, I'm a big fan of specific unit tests. When we're talking about testing, you would normally kind of associate it with like bugs or debugging or making your application more stable. But specifically for unit tests, they have a few different properties that are kind of not so apparent, but very, very important. Particularly, unit tests create a safety net that allow you to change your code in a much safer fashion. So if you have unit tests for, say, your presenter, then refactoring your presenter is much, much safer because you could change a line of code, you can rerun your unit test, and they would provide you with feedback on whether like you broke something or everything still works. So having that safety net is invaluable when you're like iterating on your code a lot. Unit tests provide you with a very fast feedback loop compared to some of the other tests. And lastly, unit tests can be used as like a test bed for your API. So if you're designing a component and you kind of want to see what is like a nice naming for your functions and what are the nice result types, writing a new unit test against that new class is a really good way to kind of feel how like interacting with this component is like. So that's another important property. So the first component we'll be testing is our portfolio repository. So what it does is essentially pulls our portfolio data from multiple sources and implements like the business logic. So like how exactly we get the data for our portfolio. So this is the interface that we have, and we'll implement it. And you can see here that we're going to be using the portfolio API. It's just our retrofit interface for executing network requests. And we'll also be using a SQLite database. So we just inject the database, and stock queries is just like the queries that we'll be running on the database. This is how we implement the logic for getting the portfolio. So essentially what we want to do is we do a network request. If it succeeds, we're going to persist our data. You also see that we're converting the data that we get from network to the domain layer. So we have like domain entities on every layer, but essentially to like communicate between, say, data and the presenter, we're going to be converting it to domain format. And if our network request fails, what we want to do is just pull the cached data from the database. So kind of like a straightforward logic. And for filtering our portfolio, here we just assume that our data is already in our database. So we'll just run a query to get the data filtered by the filter term. And let's see how we can test this portfolio repository. So first thing we're going to do is we're going to create a fake for our portfolio API. And here I'm saying fake because our recommendation in Cash App, and mine personally, is to prefer fakes over mocks. Fake and is like your own implementation of the API versus some like a mock produced by a library like Mockito. Our belief is that fakes are more controlled. There's like less sources of magic. You have more control when you implement the fake yourself rather than kind of delegating it to the library. And I can show you an example how you can create fake pretty easily. So that's essentially like the code that we're going to be using for our fake portfolio API. And you can see that we have some variables of the type turbine, and you're probably guessing what the hell is turbine. So turbine is a library that was developed by Cash App. It essentially has tools for testing Kotlin flows, not only though Kotlin coroutines in general. And the API is pretty straightforward and useful. So as you saw on the previous slide, we're going to be using a turbine, and essentially what it is just a coroutine safe data store. So coroutine safe, you could think about similar like a thread safe data store, where if you just like use shared storage, then two of your threads can be just racing for writing and reading data from it. So coroutines have the same issue that they could be racing for data. So essentially, like having a data store that can synchronize data between different coroutines is important for like coroutine safe tests. And this is what Turbine gives us. It's actually based on a Kotlin channel. And the idea is that in Turbine, you can add items to the turbine synchronously, and you can suspend when you want to extract items. So that's going to prove useful in our design of our fake. So here we're defining two turbines. One is for our portfolio objects, and the second for our exceptions, so we could test some of the failure scenarios. And what our implementation here does is that if we injected an exception into the fake, it's going to throw it. And if not, we're just going to wait for an item from our portfolio turbine. And later we'll see how we can use this fake in the test. But right now, let us finish setting up our portfolio repository test. So to fake out the database, actually, as we're going to be using SQLite, SQLite is based on the idea of SQL drivers for different platforms. And it comes with a SQLite driver for JDBC. Which is just like a local Java implementation of the SQLite driver. And this is like really useful for local unit tests. So this is what we're going to be using. We'll just instantiate our repository, plug in our fakes, and we'll write our first unit test. We're going to be using the run blocking coroutine builder to make sure our coroutines are executed in a blocking fashion. And this is how we can inject testing portfolio into our fake. So we'll just plus equal it. We're actually calling the add method on our turbine that just like puts an item into the turbine. And plus assign is just syntactic sugar for that plus equals operator. We're using the overloaded operators here. And once we injected our test portfolio, we can call our repository and verify that what we get out is what we're actually expecting. And here we can write a more complicated test. So here we're testing that if we cached a portfolio, then later on, if our network request fails with an IO exception, then what we get is the previously cached portfolio that was in the database. So that's basically our unit test for the portfolio repository. Next thing we're gonna test is our presenter. And here you can actually see that we can implement a presenter as just a composable function that returns a portfolio model or UI model for that screen. And that's kind of cool, right? That you could just use a composable for a presenter. And the way this is done is with a pretty small but quite clever library called Molecule, which essentially converts the returns of the composable functions to a Kotlin flow. Because essentially, and I actually recommend this blog post by my colleague Benoit on our code blog, where Benoit actually talks about the reactive nature of Jetpack Compose. So if you think about it, you get the inputs to your composable, and composable recomposes. So whenever the inputs change, it's going to recompose and produce outputs. So this is basically a reactive component. So if it's reactive, then it makes total sense to just turn it into a Kotlin flow, because Kotlin flows are also reactive. So that means we could just write flows with compose, which is quite cool, right? So we're going to use Molecule here to implement our presenter. What we're going to do is just define some state. We'll set loading to true. We'll launch a Jetpack Compose effect to do our portfolio call. Update our state with the portfolio once we got it, set as loading to false. And lastly, based on our state, we're going to create our UI model. That's essentially what our presenter does. So how do we test this? Very similar to the portfolio repository test, we're going to fake out our repository, because again, we're just testing our presenter. That's important. We're going to write our test. So again, similarly to what we saw before, we're gonna use like a test portfolio, put it into our fake repository, and then we will create our presenter and use the test function. And test also comes from Turbine. It is essentially an extension function on Flow, and you can see here that one of the parameters is a block where the receiver is another turbine. So it's essentially like you're testing the flow, you're getting a turbine that you can pull data from. because this one is a receive turbine, so it's kind of a read-only turbine. So very similar API. Here we're going to use it to test to interact with our flow and check, like assert on all of the items that our composable produces. So the first one is our portfolio model loading. You can see that we're calling a wait item. And the second one is the loaded, which has our data. So this is how we can test our presenter. And it doesn't have to be a composable presenter. If you have a presenter that returns a flow of UI model, you could test it with turbine as well in a similar fashion. One last thing, so when you instantiate your presenters or anything else for testing, make sure that things that are environment specific, such as a locale or a time zone, are injected rather than kind of like instantiated or retrieved inside a presenter. Because actually a personal anecdote, about a month ago I moved from Canada to Spain, so I'm currently based in Barcelona, Spain. And I just like reconfigured my laptop, set the different time zone, and ran my tests, and they failed. I was like, why did they fail? And what I saw is that, well, I was just like, I hardcoded all of the time zones, and I was just like doing time zone get default or something, and yeah, like it was working in my previous time zone, but now that I switched time zones, the test will not work anymore. So the advice here is that if you have some like locales or time zones, just make sure in test you inject some kind of set value. It could be any time zone whatsoever, but make sure that it's hard-coded for the test purposes, because you never know when where the tests are going to be running. It could be a CI server somewhere around the globe, so it's important to have that data injected. So this is all with unit tests. Now we're going to switch to integration tests, and this is like a different layer. And talking about integration tests, they're not supposed to be hermetic, so now we're actually testing collaborations between different entities. Integration tests are really useful to test integration assumptions that we make, and we'll see this in the examples. And the feedback that we get from the integration test is slower than unit tests, so they're supposed to be slower. So that's like the kind of like the downside compared to unit tests. And the first set of integration tests that we're going to write is what we want to do is just like test that we can properly parse the responses that we're getting from our server. So we're going to write some tests against our portfolio API, which is just our retrofit interface. And here's how we're going to approach it. So we'll use a tool called test parameter injector. This is a library from Google, which allows you to basically inject like a set of values into your tests. And an example of that set of values could be an enum. So we'll define our enum called fixture. And this is where we're going to specify some of the parameters that will basically describe a fixture for our tests. And what this will allow us to do is avoid repeating this and basically writing 3 tests. So we'll be able to write just 1 test, but because we're going to be injecting a fixture as an enum, the test runner is going to pass each enum into our test in a sequence. So we'll have, in general, like overall, we have 3 tests executed. So I have 3 different fixtures here for different types of responses. We have just like a default response with some data, we have an empty one, and we have a malformed response. And for the first 2, we are defining the type of portfolio that we want to see. And for the third one, we just want to see that there was an exception thrown. That's how we describe our fixture. We are going to fake out our responses by just creating JSON files that contain the data that we expect to see in the response. They could be just under the resources folder under your project. And we're going to be using mock web server to test against. Mock web server is part of OKHTTP. It's pretty easy to set up. The API is really self-descriptive. We just instantiate our web server. We can enqueue mock response. And you can see that for the body, we're just reading the JSON from the resources and using it as the body of our response. And we'll start the server. And it's actually a server that just like runs on your local JVM that your retrofit client can hit and get the responses back. We're going to instantiate our portfolio API interface. And again, important thing here is that we're injecting the base URL because the server, like as I mentioned, it's a real server running locally. It has a certain local IP. So it's important to pass that the IP or the URL to that server into our client so it knows what IP to hit. And this is how we describe our test. And as I mentioned, you see that we only do it once, but the test runner is going to make sure that for every fixture, the test is going to be executed. So we'll see 3 tests executed. But essentially, like we check that if our fixture expects a successful test, we're going to assert that the response was correct. And if not, we'll assert that the exception that we see is the one that we expect. And that's how you can, so like, if you're talking to your server and it responds JSON, I think it's very useful to have this kind of tests where you actually like you're testing the assumptions that your application is able to parse the JSON in the correct way. So the next type of integration tests we're going to write is the UI tests or the snapshot tests. So we want to protect ourselves against the visual regressions to our UI. So you see how it looks right now. So we kind of want to make sure that like when we change the UI, we're notified by failing tests. And we're going to use another library developed by Cash App called Paparazzi. And what's cool about Paparazzi is that it gives you snapshot tests without requiring a device. So it does everything on the local JVM. And there's also not a lot of magic behind it. What Paparazzi uses underneath is LayoutLib. It's essentially the same rendering engine that Android Studio uses. So you know, like when you draw your composable previews or your XML previews, you can actually just like see them in the Android Studio. This is done by LayoutLib, and it's precisely what Paparazzi does to render snapshots. And we'll see how that looks in a second. So Paparazzi is a pretty small library. You would essentially consume it through a Gradle plugin. It comes with a JUnit test rule that is very easy to set up, like you can see in this test. Here we're also using a parameter injector, but we're also injecting the theme, which could be either light or dark, because we want 2 types of snapshots. Then we create a UI model for our test. And lastly, we just call Paparazzi snapshot. It takes a composable as an argument. And here we're just passing in our position view, which is our composable describing our view. You can like just like decorate it with more composables to make it look better. And once your test is done, you would call the record Paparazzi debug Gradle task. And what it's going to do, it will create snapshots for your tests, and it will put them in a directory that you will check into Git. And those will be like the baseline for your tests. So essentially, every time you'll be iterating or review, you're going to be running Paparazzi to compare it against this baseline. We call those baselines golden files because they kind of define like what the view should actually look like. And what those look like is this. So essentially what you saw on the emulator, same here. And like as you're iterating on your view, you're just going to be calling verify Paparazzi debug. And if the task fails, Paparazzi will generate a very useful visual representation of the failure. So on the left side here, right here on the left side, you could see what's expected, and on the right side, it's what actually was there. So let's imagine we just like changed the font for our ticker text field, and it's incorrect anymore. So you can see that Paparazzi actually like shows us what the problem is, and in the middle, it actually overlays like one on top of the other. For some of the smaller changes, this is really useful, so you can see where actually the visual difference is. That's super useful for snapshot tests. Lastly, let's talk about end-to-end tests. This is like the largest set of tests that you would write. Normally, you would write them against complete flows, like a feature. It's really good for end-to-end tests to run on real hardware, so you could integrate against the devices that your customers are going to be using your app on. And the feedback you will get from end-to-end tests is the slowest because like it actually runs like an application flow. And also for end-to-end tests, one of the concerns is that there are multiple sources of flakiness. It's just a real device, so anything can happen. So those tests will probably sometimes just fail for reasons unrelated to like any bugs in your code. And we're going to test the feature to filter our portfolio. And of course, we're going to be using Espresso. As I mentioned, it's probably your go-to when you're writing end-to-end tests. And as I was like working on this demo, I actually discovered that there are new APIs for testing composables with Espresso. It was really cool to dig deep and discover those APIs. But there's like really nice guidance from Google on how you could test your UI written in Compose. But before we proceed with the test, let me tell you about a really nice technique that we use called test robots. And a test robot is essentially like a very descriptive DSL that you develop for a screen that allows your tests to look pretty nice and kind of hides away all of the complexity and all of the Espresso APIs. So here's how we can define a robot for our portfolio screen. It's basically a class. We'll pass in our test rule, and we'll define the API that just looks nice in the test. So one of them is filter. Here you can see that we will wait until our input field is ready on the screen, and we're going to perform some text input in our field. And the next API we'll introduce is check has entry, and the parameter is just some text. So we'll be checking that some of the text is visible on the screen. And this is like the API we'll be using a robot through. It kind of looks a little weird, just this function signature, but we'll better just see how it looks in our test. So here's our filter portfolio test. Just like some standard boilerplate, we're going to create our Compose Android Compose rule for our main activity. It's the activity that hosts our UI. And this is how our test is going to look with our test robot. You can see that it's really descriptive. And like a good property of end-to-end tests is that you could potentially show them to your product manager or your designer or people from other disciplines you work with. They should be able to understand what's going on under this end-to-end test because it really kind of gives this like user-level feedback. And also, like if APIs evolve or you want to do something else on the Espresso level, the complexity is hidden by the test robots. So the test is still looking nice. And Firebase Test Lab is also something that we could use, and I can really recommend it because there's like a convenient way to run your test on real devices. To set up Firebase Test Lab, you would first create a project in the console. Then you would need to set up your project to communicate with the Firebase Test Lab. And there's a tool called Flank, developed by Walmart Labs. And there was a talk yesterday by Motaz Nabil. I really hope I pronounced the name correctly. Motaz was talking about parallelizing Android UI tests, and he spoke in a lot more detail about Flank and how you could use it. Here I'm not going to go into much detail, but essentially Flank allows you to configure your project to run tests in the Firebase Test Lab. And I can recommend a project called Fladel, which is just a Gradle plugin for Flank. Fladel, as in Gradle and Flank. And what Fladel gives you is just this nice Gradle DSL to configure your project for Firebase Test Lab. So the first thing here is the authentication. To authenticate with Firebase Test Lab, you would need like a JSON file that contains your credentials. You could see that we're accessing it in the project directory, but I really recommend not checking it into Git. I will later show you how you could manage it with GitHub Actions, but it could be different depending on what CI you use. Then you could set up the variant of the application you want to use. Here we're disabling some of the performance metrics that Test Lab does. You could enable them if you want. This is like the fun part. Firebase Test Lab has a documentation like the set of supported devices along with the Android SDK versions. And you can pick what you like. Some of the names are really descriptive, like Nexus 5X. I didn't know what BlueJay is. I discovered it's Pixel 6a. So yeah, that's cool. You could set some environment variables. The one I set here is to take screenshots on failure. So whenever the test fails, the test lab is gonna save a screenshot for you, so you could see what the problem was. And here is how you can manage authentication if you're doing GitHub Actions. So as I mentioned, the authentication file is a JSON, so you could save it in the secrets in a GitHub Actions, and then during the CI run, you could just echo that secret into a local file. So then the Flywheel configuration will be able to access it, but it will also be obviously deleted once the CI run is over. So it's much safer than just storing it in your project. And once you're done setting everything up, you would basically just build your application, build the tests, and run Flank. And that's all you need to execute the tests in the Firebase Test Lab. And this is how the test run is going to look like. So here I have just past tests. If you have some of the failed ones, Test Lab is super useful at just like storing the screenshots. It actually creates videos for you. So it's really easy to kind of review just visually what the failure looked like and debug it. All right, so that's about it for our agenda for today. Let's just draw some conclusions. So first of all, the tooling for testing Android applications is awesome. There's so much good stuff from Google, from other companies, some open source libraries that make it really easy for you to set up a really good testing pipeline. I would say prioritize smaller tests. On Cash App, we have tons and tons of, just literally thousands of unit tests. We do have tests of all kinds, like snapshot tests and the end-to-end tests, but we do really rely on unit tests because they're faster, they give you a lot of feedback, and they're easier to write. And yeah, just use open source. At Cash App, we're trying to share stuff that works for us with the community. So those are some really cool libraries. So yeah, please use them and provide feedback and contribute. That's what open source is for. And that's it for today. Yeah, my name is Egor. That's my Twitter and GitHub handle if you want to find me online. I'll also be around if you want to chat about testing, open source, Cash App, anything at all. Thank you so much. It was a pleasure.
Thank you so much, Egor.